Hi everyone, this is Mrs. G, and today we are going to be talking about complex numbers, but first pause the video for this quick warm-up. Alright, go ahead and check here. So in this first one I used the square root method, but I ended up with the plus or minus square root of a negative number, which we know means that there are no real solutions. And then for part B, I chose to set this equation equal to 0 and factor. So here are my factors giving me these two solutions. Now, as we just talked about in the warm-up, whenever we have the square root of a negative number like this, or like in the warm-up, we say that it has no real solutions. But now we're going to talk about a way to actually provide an answer when we have the square root of a negative number. And this is really expanding the system of numbers that we're working with using what are called imaginary units, which are represented by the variable I. So whenever you see the variable I in math, by definition, it is equal to the square root of -1. Now, I would like to point out that this is called an imaginary number. We know that there is no real number that is equal to the square root of a negative. But again, it's just a way to keep working once we kind of get to this stopping point. So anytime you see I, it's important to know that it represents the square root of -1. And anytime we have the square root of a negative, we're going to keep simplifying that using I. Now, it is also going to be important for us to simplify powers of I, just to make sure our final answer is as simplified as possible. So if you just have I to the power of 1, that's always just going to simplify to I. Now, the second one is probably the most important one to know. By definition, I squared is equal to -1. So that's a really important one to know. Now, if you ever see I cubed, that's going to simplify to -I. If you think about it, I cubed is simply I times I squared. I times -1 is -I. And if you ever see I to the power of 4, that's going to simplify to +1, which hopefully makes sense because I to the power of 4 is I squared times I squared. -1 times -1 is +1. So you'll see as the powers of I increase, it will start following this pattern. It will equal I, -1, -I, 1. And then as you increase in power, so if you get to I to the 5th, you actually go back to the start of the pattern. So I to the 5th is I to the 6th is -1, I to the 7th would be -I to the 8th would be 1. And then that pattern just repeats. So it kind of follows this pattern of 4 different powers, and then it just replicates. So we will practice simplifying those higher powers of I today. We're also going to be talking about just this idea of a complex number. So a complex number is a number that has two parts. It has an imaginary part and a real part. So we write it in the form of A plus BI. So all of these could be considered complex numbers. However, if B is equal to 0, so if you don't really see that imaginary part, we can classify that further as a real number. Still could be considered a complex number, but the more specific way would just be a real number. So if you don't see an imaginary part, we can call it a real number. Now, if you see both a real and an imaginary part, we call these imaginary numbers. And if the real part is equal to 0, so if A is equal to 0, then we could classify this as a pure imaginary number. But again, all of these are in the realm of complex numbers, and they should be written in the form of A plus BI, where that real part is first and the imaginary part is second. And then we're also going to talk about this idea of complex conjugates today. So complex conjugates are pairs of complex numbers in the form of A plus BI and A minus BI. So essentially, you'll just see that these middle signs are opposite, and B cannot equal 0. So we'll talk a little bit about these today and what happens when we multiply complex conjugates. All right, so we're going to start out by just simplifying some expressions where we have the square root of a negative number. So anytime you have a square root of a negative, the first thing you can do is just get rid of the negative by placing an I out front. And then from there, you just go ahead and simplify the rest of the radical as you would any other radical. So this we would just call 5i. And if you're comfortable going straight from here to here, totally fine. So again, we see that negative inside, so I know that the square root of -1 is I. So we can write it as I root 72. But then from there, we need to keep simplifying. So I know that 72, we can actually write that as 36 times 2. And of course, 36 is a perfect square, so it becomes 6I root 2. So again, using imaginary units allows us to simplify an expression where we have a negative inside a square root. Let's try this last one together. So here we have that negative on the inside, which gives us an I on the outside. It does not make that negative out front disappear. The I only makes the negative in the radicand disappear. And then from here, we know that the square root of 9 is just 3, so this would just become negative 15I. So that's how we're going to be simplifying any expressions, again, with that negative inside our square root. All right, so at this point, go ahead and pause the video and give these examples a try. All right, go ahead and check your work here. So again, just make sure that all of your answers are fully simplified. We would no longer stop here and just say no real solutions. We're actually going to give solutions that are imaginary or complex. All right, so now we're going to practice simplifying expressions with higher powers of I. So as we talked about on one of those first slides, those different powers of I, we know that I to the fourth equals positive 1. So if we can pull out as many groups of I to the fourth as possible, those will all simplify to 1, and then we'll just have a smaller degree to work with. So if I see I to the 13th, we know that that's I to the fourth. Well, 13 has 3 groups of 4, and then an additional I, because this would give you I to the 12th, and then that extra power of I is right here. And again, we know that I to the fourth is equal to 1, so this expression is equal to 1, and all we have left over is just I. So that's going to be our strategy to pull out as many groups of I to the fourth as we can. Now for this one, we can write as I to the fourth to the 12th, because there are exactly 12 groups of 4 and 48. So this expression actually just simplifies to positive 1. Now here, if you ask yourself how many groups of 4 are in 30, we would say 7, and that's I to the 28th. So we need 2 more powers of I, so it'd be times I squared. So again, this portion simplifies to 1. All I have left is I squared, and we know that whenever we see I squared, it will simplify to negative 1. And last, how many groups of 4 are in 19? Well, we have I to the fourth. There's 4 groups, which brings us I to the 16th. So then we still need to multiply by I cubed. This is equal to 1. So what we have left is I cubed, which equals negative I. So remember, it's I squared, which is negative 1, times I. So that's how we get that negative I. So that's how we are going to be simplifying those expressions with higher powers of I. Again, just pull out as many groups of I to the 4 as you can. All right, so now we're going to talk about how we can add or subtract complex numbers. So adding and subtracting complex numbers is just like adding and subtracting with any other variable. It's literally just combining like terms. So when I'm adding these two complex numbers, I'm really, those parentheses don't even do anything for us if we're just adding. And again, from here, I'm just combining like terms. I'm going to add the real parts together, and I'm going to add the imaginary parts together. And when it says to write that answer in standard form, it means in this form, so the real part should be first and the imaginary part should be second. So we just have 13 plus 3i. And if we're subtracting two complex numbers, again, it's just like adding or subtracting with any other variable. We just need to make sure we distribute that negative. So it's just 7 minus 6i minus 3 plus 6i. Then we're going to combine the real portion, and here the imaginary portion actually just becomes 0i, so we just have a real number, and it's just equal to 4. So again, I really acts like any other variable until you go to simplify the higher powers. All right, so now let's try multiplying complex numbers. So again, when we do that initial multiplication, it's just like with any other variable. Here, we're actually just going to distribute 4i to our binomial. So we get negative 24i plus 4i squared. So notice, just like x times x is x squared, I times I is I squared. Then from here, we just need to make sure we are simplifying our higher powers of I, specifically in this case, I squared. So we know that I squared is always going to be equal to -1. So now we can write our complex number as -4 minus 24i. Just make sure to write that real portion first for your final answer. All right, now we have a binomial times a binomial, two complex numbers. We're just going to FOIL it out, just like we would any other two binomials. So we'll do our first term here times our second binomial. So we have -36 plus 63i. And then we could do our second term times our second binomial here. So we have plus 8i minus 14i squared. Now we are going to be combining our I terms here. So we get -36 plus 71i. And then we're also going to remember that I squared is equal to -1. So we have minus 14 times -1, which of course becomes positive 14. So now I'm just going to combine these two terms to get my final answer of -22 plus 71i. So just look for ways to simplify or reduce your higher powers of I, and then combine any terms that are the same. But again, you can see that it's really similar to multiplying with any other variable. All right, so now I have a couple different types of examples for you to try on your own, so please pause video and hit play when you're ready to check. All right, go ahead and check your work here. So you can see here we just needed to make sure to distribute that negative before we combine. Here we can rewrite this as I to the 4th to the 5th, which leaves us with I cubed left over, and then we just simplify I cubed to -I. And then here, FOIL it out, combine like terms, and remember I squared is equal to -1. All right, so now we're going to return to that concept of the complex conjugate. So here we're going to multiply 5 plus 2i by its complex conjugate, which would just be 5 minus 2i. So for a conjugate, we simply change the sign of that, change that middle sign. So plus becomes a minus. And now let's multiply it out and see what happens. So we get 25 minus 10i plus 10i minus 4i squared. So maybe right off the bat that you notice that these terms will cancel out. And then when I go to simplify further, because I know that I squared is equal to -1, I see that I actually don't have any I left over at all. So when you multiply by a complex conjugate, it actually turns your expression back into a real number. One thing you will also see is that when you have solutions to equations that are complex numbers, they will always come in pairs, and those pairs will always be those complex conjugates where, again, if you multiply them together, you end up back with that real number. All right, so now go ahead and pause the video and try this one on your own. All right, go ahead and check your work here. So here, this one, we have 3 minus 4i, so its complex conjugate is 3 plus 4i. You see when you multiply them together, all of your imaginary units are cleared and we're left with just 25. So now that we know how to work with these imaginary units, we're going to try solving some equations that have complex solutions. So let's look at this first example. Here we can start, let's try using that square root method. So I'm going to start by isolating my squared term, my x squared term. So we get x squared equals -18. And then from here, I can take the plus or minus square root of both sides. Now previously, this is when we stopped and we said no real solutions, but we know now that we have a way of simplifying this. We still have the plus or minus. I'm going to pull the I out front, and we know that 18 is just 9 times 2. So this will have two solutions, plus or minus 3i root 2. So in this case, we have two imaginary solutions, positive 3i root 2 and negative 3i root 2. And you'll see that imaginary or complex solutions will always, always, always come in pairs, and those pairs will always be complex conjugates. Now, let's look at the second example. Let's say I wanted to try to solve this by factoring. And I notice there's a GCF of 4, so maybe I factor out the 4. And then I go to do my zero product property, and I still have that kind of that square root method that we talked about. So I'll subtract 5 from both sides, and then I'll take the plus or minus square root of both sides. And then here, instead of saying no real solutions, I'll just move that I out front, and we have plus or minus I root 5. There you go. So notice again, we have 2 solutions, and they are complex conjugates. All right, here's the last set of u-tries. So for the last time, please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. Make sure your answers are fully simplified, and please make sure you have those plus or minuses out front. Again, whenever we are the ones initiating the square root of both sides, it has to come with that plus or minus. All right, that is all for today's video. Thank you so much for watching.